Uh, I we may start it right now
Sure,
because
sir.
all the panelists are the present, so we may start.
Sure, sir.
Good afternoon, everyone. I'm Anisha Bose. I'll be hosting this session today. So, we have a panel discussion today. We have six teams.
Uh,
They
I
will get 5 minutes
I
for
may we
each
may
team
start it
to
right now
discuss their project.
because
Sure,
And
sir.
after
all the
everyone is
panelists are
complete,
the present,
we will
so we may start.
have a 30 minutes
Sure,
group
sir.
discussion. And
Good afternoon,
if you
everyone.
have any
I'm
question
Anisha
and answer,
Bose.
you
I'll
can
be
ask
hosting
after
this
the five
session today.
minutes. So we have a panel discussion today. We have six
5 minutes
teams.
Uh,
Presentation. So let me give you guys the order in which you guys will be presenting. Give me just a minute. Uh, Okay, so is the first team ready? So the first team is Utshab Dash and Orchid
Yes,
Chaudhary.
ma'am.
Yes, ma'am.
Firstly, it will present and then I will continue.
Sure. Okay. You guys will get 5 minutes for this presentation. You should share your screen and start your presentation. Okay. First team ready. Over to you, Utshab and Orchid.
Okay, ma'am. Good afternoon, everyone. I am Orchid Chaudhary, and alongside with Utsav Das, we present to you Cyber Sentinel, a real-time data security system for mobile apps. Let's get started then. Now, coming on to the motivation of our project, have we ever wondered which apps on our phone are secretly tracking us right now? Our camera app has accessed our location, a game shared our contacts. We have no idea. Mobile app data breaches have grown nearly 10 times from 50 in 2018 to 470 in 2025. A single compromised app can expose everything, even the smallest of the details. It's our app Sentinel's objective is simple: close that gap with real-time permission monitoring and actionable feedback so that users stay in control. Now, coming on to the methodology of our app, Sentinel is a five-layered, fully on-device privacy monitoring system for Android, meaning no data ever leaves our phone. It works in two key concepts. First, it intercepts our app's outgoing network traffic using Android's VPN API and analyzes the DNS queries and packet headers locally. Then it calculates a privacy risk score for every app based on its permission sensitivity, usage intensity, and network behavior. If something looks suspicious, Sentinel instantly sends us a context aware to look into that. It's built on Kotlin 2.1.0 on Java 17 using MVVM architecture, Jetpack Compose for the UI, and a custom IP DNS parser over local TUI interface. Now, coming on to the risk quantification model of our app is based on a private PRS score. That is, PRS equals to alpha into sensitivity level plus beta into usage intensity plus gamma into network behavior. Our PRS range stands from 0.0 to 0.3 to risk level low, and then 0.3 to 0.6 moderate risk level, then 0.7 to 1 high risk level. Now, coming on to the privacy risk algorithm, we have used weighted linear scoring algorithm that estimates the privacy risk of each installed apps, getting a score between 0 to 1, where higher value indicates greater risk. Here, sensitivity measures how an app's granted permissions are, like it's based on the weighted sum of base score and sensitivity bonus. Then usage intensity, which is a recency-based decay metric, estimating maintenance activity via last update, and network behavior. It scores a data transmission potential via network permissions, where known internet means 0 and internet present means 0.5. From here onwards, my teammate Utsav will continue.
Um, Now I will tell about the dataset which we have used for testing. Our dataset consists of 10,000 popular Google Play Store apps, each described by 11 metadata features, including category, monetization, ratings, etc. Every app is annotated with 5 risk tiers, from benign safe to ransomware high risk. These features serve as proxy signals for our three PRS subscores: SL, UI, and NB. Key features are: one, app metadata. It includes app ID, app name, and developer name. Categorization. All the 10,000 apps are categorized into 27 categories into broad 5 groups. A monetization model, 3 revenue types: free, premium, or subscription based. 4, user engagement signals. Play Store ratings from 1 to 5 and download counts are proxies for usage intensity, and ground truth risk levels are used for validation. Now, I would like to represent a ground truth risk distribution where we can see that 7,000 apps are in low risk, almost 2,200, that is, which contain adware and spyware, are in medium risk, whereas only 800 out of 10,000 apps are high risk, which consist of malware, Trojan, or ransomware attacks. Studying our data set, we have found out that 72% of our audience are adults, 16% are IT professionals, and rest all are teenagers and children. Now, evaluating Sentinel with 3 existing models. Sentinel was also evaluated against form score, Mars, and privacy grade, which was already been specified in research papers across 10,000 Play Store apps. Form score focuses purely on permission sensitivity. Mars factors in app popularity and ratings alongside risk, and privacy grade personalizes apps only when their behavior deviates from user expectations. Statistically, we have compared Sentinel with Form Score, Mars, and Privacy Gate, and we have found that Sentinel's mean score is highest, 0.458, and it has the lowest standard deviation, 0.105. By unifying behavior, sensitivity, and usage into a single score, Sentinel delivers the most comprehensive risk assessment of the 4. Now, talking about our results and outcomes, upon being tested on a real device across 65 real-world apps, Sentinel detected 94% of them accurately, delivered real-time alerts in under 200 milliseconds, and confirmed zero data egress for a one-day check. All of this with less than 1.8% battery usage and 85 MB of RAM. Future scope: 1, we would like to recommend a safer app alternative for high-risk apps. 2, we would like to leverage OS accessibility to prevent camera, microphone, and screenshot control. And 3, we would like to build a decentralized privacy cloud to improve data encryption to prevent zero-day threats. Now, I would like to present a live demonstration of our application.
Utshab, I'm sorry to cut you off, but like you have crossed 5 minutes, you can get
Okay,
hardly
ma'am.
1 or 2 more minutes to show your live demonstration. Okay, just make it quick.
So, ma'am, I will take only 1 minute.
Sure, sure. Just make it quick.
Okay, ma'am. So, as you can see, Sentinel consists of 5 distinct sections. Firstly, dashboard section. It is the real-time hub or the primary home stream. It runs a background service, that is the live awareness. Upon clicking on it, we will get real-time alerts about how apps are accessing our sensitive permissions. We have categorized all the install apps into 3 categories: high-risk apps, medium-risk apps, and low-risk apps. By clicking on any app, we would get to know about the list of denied sensitive permissions and um, provided sensitive permissions to that app. Talking about the app section, it is a full list of all installed applications with their exact risk scores and breakdown of risky versus safe permissions. Tapping a permission guides us straight to Android settings to revoke it. Now, talking about the Insights section, Insights is a live network monitoring section. Each app gets a app card showing blocked versus allowed traffic, and we can toggle using the firewall protection toggle card to block the internet access of that app. Privacy section is a permission centric view of all the permissions granted to every app of our device. It groups the permissions into dangerous, normal, and signature categories, so we get to know what's a risk. And lastly, settings. It shows the profile management, dark mode, auto app start, alert frequency, and block tab manager. That is a full control of all specific features of our app in one place. Thank you.
Thank you, Utshab and Okit. Your presentation was good. So, moving on to the next group, Shrayan Mishra and Rituraj. Do you have Shrayan Mishra and Rituraj? Shrayan and Rituraj. I guess they're not in the meeting right now, so we
We
will
can
move.
move to the next presenter, next team.
Yeah. We have the next team, Bhanu Barrier and his team. Do you have Bhanu? Hello? Okay, Bhanu is here. So
Yes,
Bhanu, you'll
ma'am.
be presenting, right?
Janatul will start and then I'll take on.
Okay, sure. Over to you guys.
Good afternoon, everyone. I'm Jannatul Firdaus, and today I'm presenting EvolNet, an evolutionary network growth model for structural and temporal characterization of web hyperlink graphs. This work investigates whether the structural and evolutionary behavior of the World Wide Web can help us distinguish legitimate and malicious domains using principle from complex network sites. The web is a directed network of websites connected by hyperlinks, importantly internal links within a domain and external links between domains serve different roles. Most studies treat them the same, but EvolNet separates them to better capture the web structure and evolution. Despite significant advancement in malicious website detection, several important limits remain. Existing approaches primarily focus on the statistic snapshot and ignores temporal evolution. Internal and external hyperlinks are often merged. Most approaches do not model hyperlink growth laws such as preferential attachment, triadic closure, densification, associativity. Additionally, hyperlink targets are frequently unlabeled and edge weights are generally treated ununiform. These limitations motivate us to build EvolNet, a framework that studies how the web evolves rather than only how it appears at a single point in time. Our work is driven by the three research questions. We investigate how website structures shape web organization, how the structures evolve over time, and which network metric best explain web growth and dynamics. Now, Bhanu will explain the methodology section.
Hello, everyone. Here in our model, we model our web as a weighted directed graph. Nodes correspond to URLs or domains. Edges correspond to hyperlinks. Each edges receives a weight based on hyperlink context and semantic similarity. Unlike earlier versions, our graph uses only weighted edges and doesn't employ any side edges. The methodology consists of 6 sequential stages: URL crawling extraction, URL canonicalization, graph construction, temporal snapshot construction, metric computation, comparative analysis. This pipeline transforms raw web data into a network representation suitable for both structural and temporal investigation. Um, then in macro analysis, it's kind of a static snapshot modeling. The first analytical perspective is static snapshot modeling, where we do centrality analysis and we compute in degree, out degree, betweenness centrality, closeness centrality, eigenvector centrality, as well as local clustering coefficients. These centralities form the structure profile of every node. Then we perform macro level analysis of weighted directed graph, which is done on the basis of component analysis and distribution analysis. In component analysis, we identify SCC, WCC, which are strongly connected components, weakly connected components, as well as giant components and bow tie structure to understand global connectivity. And in distribution analysis, we study degree distribution, in degree distribution, out degree distribution, edge weight distribution, path length distribution, and clustering distribution to verify scale-free and small world behavior. And on distributional analysis, it is also done on 3 different levels: univariate, bivariate, multivariate, where we analyze hubs and bridges, as well as community detection and motif analysis. In hubs and bridge analysis, we take top 2% of degree centrality scores and mark them as hubs. And those hubs which are connected to another hubs, we mark them as bridges to identify the linkage. And in community detection, we have used Luvian community detection to identify clusters and optimize modularity. This helps us understand whether the malicious domains remain isolated or infiltrate legitimate communities. Finally, we analyze recurring 3-node motifs to capture microscopic connectivity patterns that characterizes legitimate and malicious systems. Then we study higher order growth mechanism. We measure whether similar nodes tend to connect together or not. Assortativity is computed with respect to degree, in degree, out degree, betweenness, closeness, eigenvector centrality scores, and local clustering coefficient. Positive assortativity indicates similarity driven attachment, while negative assortativity suggests dissimilar interactions. Then we come to the next part, triadic closure, where we examine the triadic communities. If suppose there are three different nodes, if a node A connects to node B and B connects to node C, then A is likely connected to C. Clustering coefficient and closure fractions quantify this tendency. Legitimate websites are expected to exhibit stronger closure behavior due to organic growth process. And as for attachment modeling and temporal evolution, a major contribution of Walnut is hyperlink attachment modeling. Every new hyperlink is treated as an attachment event. We estimate attachment probability and evaluate whether new links preferentially connect to structurally important nodes or not. The analysis is conducted at three levels, which I mentioned earlier: univariate analysis, where attachment probability versus individual centralities can be seen; bivariate analysis, where interactions between pairs of structural measures are shown; and multivariate analysis, which is the combined influence of all centrality dimensions. And for temporal modeling, multiple crawl snapshots are analyzed. We specifically analyzed four attachment scenarios: legitimate to legitimate, legitimate to malicious, malicious to legitimate, malicious to malicious. These scenarios reveal how trust, authority borrowing, and malicious ecosystem formation evolve over time.
Manu,
Next,
I'm so sorry to cut you in the middle. You were done with your 5 minutes, I guess. You have to make it a bit faster.
yes, ma'am. The next is the results section, which will be explained by Janatul.
Our findings indicate that the web constantly exhibits scale-free characteristics and strong community organization. Legitimate domains occupy central hub's position, exhibit stronger homophily, higher clustering, and more stable community membership. Preferential attachment and triadic closure are significantly stronger in legitimate ecosystem. Motive structure, bridge connectivity, and temporal attachment pattern reveal clear differences between legitimate and malicious domain. These structures and temporal significance provide a powerful basis for malicious web characterization. Future scope will focus on real-time web monitoring, multi-layer graph modeling, graph neural networks, temporal GNNs, early phishing detection system. Explainable graph-based cyber threat intelligence. To conclude, Evolnet combines graph modeling, macro network analysis, community detection, motive analysis, homophily, triadic closure, attachment modeling, and temporal evolution in a unified framework for understanding web growth. Thank you.
Thank you, Bhanu. Thank you, Jannatul. Now we will be moving on to our next presentation and the next team, Debashish Chakraborty and the team. Do you have Debashish in the meeting?
Yes, I will present now.
Okay, over to you, Debashish.
Uh, the screen is showable. Everyone can show the screen.
Yes, your screen is visible. You can start.
Okay. So, good morning, everyone. Today, I will present our work who are emerging researchers, a data-driven approach to identification early career scholar. Identifying promising researchers at an early stage is important for funding agencies, universities, and research organizations. However, there is no clear and objective way to define who an emerging researcher really is. Our work proposes a machine learning based framework that uses bibliometric data to identify emerging researchers more accurately. Now, the main challenge is that the definition of an early career researcher or ECR is highly subjective. Traditionally, researchers are classified based on factors like age, years, since PhD, or institutional rules. This creates several problems like collaborations barriers, funding inequalities, and recognition gaps. As a result, many talented researchers may be overlooked despite showing strong research momentum. Ultimately, our objective is to solve the problem. We aim to operationalize researcher identification using machine learning. Current methods depend on arbitrary timelines and citation-based measures. Our proposed approach moves towards an objective and dynamic system that evaluates publication continuity, collaboration pattern, and research momentum. This allows a more data-driven and fair identification process. Um, Mainly, our framework consists of three major steps. First, we collect and process bibliometric data from the EMNA dataset. Second, experts annotate and sample the data to create balanced training instance. Finally, dimensionality reduction techniques such as PCA and feature selection are applied to identify the most informative predictive features. Now, instead of relying only on citation counts, we consider multiple indicators of research momentum. Traditional features include citation count, H-index, and P-index. We also introduce dynamic features such as collaborator count, publication gaps, and citation growth rate. These features help capture the growth trajectory of a researcher rather than just past achievements. The results are highly encouraging. Among several machine learning models tested, ensemble method performed best. XGBoost achieved 99% accuracy with AUC of 1, followed closely gradient boosting, random forest, and logistic regression. These results demonstrate that our framework can reliably distinguish emerging researchers from established scholars. Now, feature importance analysis provide an interesting insights. The most influential factor were collaborator count, publication gap, citation growth rate, and citation growth velocity. This shows that research trajectory and collaboration pattern are much stronger indicators of future potential than simply counting past citation. Now that come to the future scope and conclusion. To conclude, our framework provides an scalable and objective way to identify emerging researchers using bibliometric data and machine learning. In the future, we plan to expand across multiple disciplines, incorporate real-time datasets, and apply advanced deep learning techniques. Our long-term goal is to support further research evolution and help discover future scientific leaders more effectively. Thank you everyone for listening. So thank you everyone.
I think we can move to the next
Thank you.
presenter.
Thank you, Devashish. So we can move to the next presenter. Kali, Neha, and Srishti. We have them in the meeting with us.
Yes, ma'am.
Yes. Okay. Over to you, Kali.
Okay, so good afternoon, everyone. Today, I will be presenting my work on GeoPhenoBench, a benchmark dataset we built for medicinal plant identification. I will quickly walk you through the motivation, what we did, and our the key findings, and where this can go in the future. So let's start with the motivation. Misidentifying medicinal plants is dangerous. A wrong treatment can be useless or even toxic. Two big problems make this hard. The same species can look very different depending on geography, something called geo-induced phenotypic plasticity, and many toxic non-medicinal plants look almost identical to medicinal ones. Existing datasets are label-based, single reason, and don't capture this real-world variation. So our main objective is to build GeoPhenoBench, a large-scale geo-tagged benchmark dataset of medicinal plants collected from real field conditions across multiple continents, specifically designed to study geo-induced phenotypic variation and support robust plant identification research. So, to to address this, we built GeoPhenoBench from iNaturalist data. We collected approx 136,000 research-grade geotagged images of 32 species via the iNaturalist API. We applied quality filtering, removing blur images, bad exposure, and missing geotags, removed duplicates, and resized everything. The final dataset has 98,000 approx images with 15 metadata fields, including species, latitude, longitude, country, continent, and accuracy. Organized it into continent-wise folder. Now, our most important finding from the EDF. First, there is a natural class imbalance ranging from 1208 to 8,724 images per species. This reflects real citizen science bias. Second, there is a geographic skew towards the US at 26.6%, but the data still spans 6 continents. Third, positional accuracy is high with a median of around 10 meters. So the fourth one is we confirmed real phenotypic differences across region. For example, aloe vera, tulsi, and neem look visibly different across continents. But finally, we concluded 28 medicinal species plus 4 visually confusable look-alike species, the first data set to do this. So looking at the future direction, we plan to add pictures of plants across different seasons and growth stages like flowering, leaf, and dried forms. We also want to include environmental info like soil type, climate, and elevation, not just photos. And we want to test whether an AI trend on plants from one continent can still recognize the same plant in other continent. So as for the end product, we envision a simple mobile app like a Google Lens for medicinal plants. A person click a photo and the app tells them the plant name, whether it's a medical and wants if it's a toxic a look like. This would be useful for farmers, herbal medicinal practitioners, students, and even tourists. This kind of app could also align with government initiatives like the National IOS mission, which focus on quality and authenticity of herbal raw material. So finally, some collaboration ideas. We would like to work with botanists and Ayurveda expert to verify medicinal properties and look alike more accurately. Partner with AI research group to test how model trained on our data perform across different countries, and collaborate with environmental and conservation organizations to track endangered medicinal plant species using this dataset. Now, Neha will present the federated learning part. Neha, please continue. Neha, are you there?
If
Two
Neha is
minutes,
not
more minutes left.
if Neha is not
You can also present if needed.
we can move to the next one.
Okay.
Okay, thank
So
you.
moving on to Kali, will you present more?
No, ma'am. Thank you, ma'am.
Okay. So moving on to the next team, Onisha and her team. Do you have Onisha with us? Or anyone from her team?
Yes, ma'am, we are there.
Yes, ma'am.
Okay. You guys can present now.
Yes, just a second. I hope my screen is visible.
Yes. Your screen is visible.
Thank you.
Good
Good morning,
afternoon.
everyone.
Who is starting?
You may start.
Okay. Good afternoon, respected panel members. I'm Ritika Singha and I will be starting our presentation. Our project is titled as Recognizing AI Generated Handwritten Answers based on a multimodal and multilingual framework. Change the slide, please. Our motivation of the problem. The motivation behind our project comes from the rapid growth of AI tools such as ChatGPT and Gemini. While AI has many benefits, it also creates challenges in the education sector. Students can generate answers using AI and then rewrite those answers by hand before submitting them. Traditional plagiarism detection tools mainly work on digital text and cannot effectively analyze handwritten answer scripts. During our research, we found that existing solutions either focuses on handwriting analysis or text analysis, but very few combine both approaches. This research gap motivated us to develop a framework that can analyze both how an answer is written and what the answer actually contains. The main objective of the work. Next page, please. The primary objective of our project is to develop a system that can identify whether an answer script is handwritten or AI generated. To achieve this, we proposed a multimodal framework that combines the visual handwriting analysis and semantic text analysis. Our dataset includes answers written in English, Hindi, and German. We collected data in three categories. One is original handwritten answers, AI generated handwritten answers, and AI generated digital answers. The next part would be continued by Vasundhara.
Please change this slide. Okay. So we have used a unified detection architecture over here, combining CNN-based image analysis with OCR-driven NLP processing for robust multi-class classification. So for branch A, that is visual analysis, we have first taken input, that is raw image dataset, that is web scraped and originally handwritten by us. Then we have processed those images. Then we have used the CNN model for visual feature extraction. Then after processing and running a stratified fivefold classification model, we have classified the output into three categories or labels, that is original, AI handwritten, or AI digital. In branch B, that is semantic analysis, we have also taken the same input, that is the same image data set. Then we have run the OCR, that is used is Pi Tesseract. Then we have done the NLP processing, and then we have used the textual feature extraction to run the feature fusion layer. Please change the slide. So the two detection models that we have used, they are the handed for visual analysis and Raga for semantic analysis. For handed, we have used the CNN-based handwriting analysis. So this is done via image pre-processing and augmentation. That is 1:1 static augmentation. Then we have done stroke and texture feature extraction, classification by handwriting style, and then in the visual anomalies in pen strokes are being detected. The next part will be presented by my teammate Arun.
So for the NLP part, we have basically first used OCR to extract the text, and then we have used two pipelines. The first pipeline is surface level check, and that is document formatting, style layout, and then text features, argument mining. And then for pipeline B, we have used deep semantic embeddings like mini LM, mini MPNet, and then multi QA. Among that, we have mostly kept the mini LM results. And for the final results, please change the slide. So for the final results, we have got two standalone results. That is, for NLP, we got about 95% accuracy using SVM, and then for CNN standalone, it was 85%. So we have decided to then concatenate the results, and we have done this in three phases. For the first phase, we used three languages: English, Hindi, and German, and we got a global accuracy of around 68%. So we have found that the um, reason for such low accuracy was because of the non-Latin script, which was in Hindi, and AI handwritten category showed a lot of false negatives. So for that, we have used another phase two result. That is, we have only kept the English and German results, and then the global accuracy jumped to around 87%, showing that the non-Latin OCR was the bottleneck, and AI handwritten false negatives also dropped. So finally, we have decided to present the results as optimized multimodal. That is, we use the Latin subset and 1:1 visual augmentation. So the peak threshold which we have reached of global accuracy is 90%, and we did this using two vectors from CNN and NLP, and we have concatenated them. And so the final AI handwritten false negatives has reduced. So this is what we did. So for future works, we have decided to keep the non-Latin scripts, and those can be worked on more. And this is what we did for our project.
Thank you, Rohan, for your
I think Neha is now present. Okay, and there was a technical issue. Due to that, Neha was not able to present. Neha will be presenting now.
Other than that, Shayan Mishra and Rituraj's team is still
Rituraj
left.
is still not present. I think if he's not present, then definitely we can skip that portion. We
Okay,
can
then
direct for the
we
next
can move.
session.
Okay, we can move forward with Neha. Is Neha going to present now?
Yes, ma'am.
Okay, Neha, you present. You will have 5 minutes, okay?
Okay, ma'am.
3 to 5 minutes for the presentation.
Good afternoon, everyone. I am Neha Mahato, and I am going to explain the federated learning. So, federated learning is a machine learning technique where multiple clients train a model together without sharing their original data to central server. Client only sends model updates or weights to the server. This helps to maintain data security and privacy. In federated learning, first of all, the central server sends the global model to all the clients. Then to each client train the model using its own local data. After training, clients send only updated weights to the server. Then the server combines all the updates and weights from the client and create a new global model, and this process repeats for many rounds until the model becomes accurate. So we have used three aggregation techniques. We have used three aggregation techniques that are Fed average, Fed prox, and Fed yogi. In Fed average, uh, server calculates the average of all the client model weights and update the global model. In Fed prox, server add a proximal term during aggregation, which reduce the large difference between the global and the local model. In Fed yogi is the optimization technique we have used, where it controls the learning process and updates. It provides better convergence and stability. It also tells how global models should change. Now the results. So from the results, we have got that ComNext achieved the best overall result with Fed average reaching 92.61% accuracy and 0.9804 AOC ROC metrics. VGC 16 also performed strongly achieving over 90% accuracy. RaceNet 50 and CNN also showed performance but with lower accuracy. And from all the algorithms, we got that fed average is best. Now we will move to the result section. This is the result of all the deep learning models with the algorithms. Next, these are the ROC curve for fed average, fed prox, and fed yogi for all the deep learning models. This is the comparison of Connext. This is the comparison of Connext performance using fed average, fed prox, and fed yogi. Next, we'll move to future scope. In future scope, we will develop a real-time mobile or web application for better data security and privacy of images, and we'll also train and compare additional deep learning models to achieve higher classification performance. We'll expand the dataset also, including more species and images, and we'll also train some deep learning models for better model accuracy and optimization. Next, we'll move to conclusion. So we can conclude that among all the models we have trained, we have got that ConNext achieved the best performance in all the three algorithms due to its advanced architecture and efficient feature extraction capability from the images. Overall, we can say that federated learning is powerful for secure and collaborative AI system. We can also make some secure and privacy preserving models system in future for medicinal plant image classification. Thank you.
Thank you, Neha. Thank you for the presentation. Now that we are done with all the groups, we will start a group discussion now. We have 30 minutes. All the groups have 30 minutes for the group discussion. So we may start the group discussion.
So any one group can initiate their process, and we can go for the group discussion. So raise the points and discuss. And if you actually, I have given the, we have discussed that if we go for some kind of collaborative work in between the teams, then they can also proceed for that one. Okay, so discuss that matter.
I'll request a team to initiate their point and to start the group discussion.
Bhanu, you start it. Other people will join over there.
Recently, Arpit has called me for the collaboration idea with his severity detection app. I want to know a lot more about it. Before asking any question, I want to know what he really wants to improve. Arpit.
So as I have presented here right now, our app is a mobile app. It's not a web-based or any network-based app. So what it does in mobile completely offline. It's not based on any web browser. So my and Utshav's idea was to move forward after developing the fully Android app and then go to the web extension. Like earlier, I have saw your topic about the URL and the maliciousness of the URL. So that piqued my interest quite a bit. So about that, I want to do that.
Extensions might not be a good idea because extensions actually they are very easy to create, no doubt, but to analyze about a URL in depth, if you want just an answer whether a website is malicious or legitimate, you can find it with a extension. There are hundreds of extensions already present. But what I was trying to do, I already discussed with Ajit sir also. Have you ever used SEO platform, search engine optimization?
Not fully, but
Not
I have
fully.
tried a little.
Suppose you just open any SEO optimization page, and there you just have to input a website, and that platform will tell you about the websites, all the optimizations, what you are needed to do, what you are already doing, what are incorrect implementations, and what can be done to improve the traffic of that website, particular website. Okay, so that you can so that it can be seen in the Google feed. हम लोग देखते हैं ना कि बहुत सारे फीड्स आते हैं गूगल साइड बार्स में.
हाँ हाँ.
That's done with the help of SEO optimizations. The more your SEO score will be, the more frequently those sites will appear in your feed, and it will gain popularity. Just like that, we wanted to make a platform where we input a website or URL. It will define each and every perspective of that URL, how the URL is connected, how it is influencing it, what are its nature, what are its behavior, what are the sites that are linked to it, what are the external domains that are linked to it, how it is changing over the time. Because we mostly uh, observed that a malicious URL is generally having a low life, 30 days max, because
Okay.
there are many cybersecurity algorithms which can detect them, just like cybersecurity force also. So to maintain that, क्या बोलते हैं उसको, उससे बचने के लिए वो लोग बहुत लिमिटेड टाइम के लिए डोमेन्स यूज करते हैं, कोई भी डोमेन. एंड देन
Temporary domain. Do you mean temporary?
if you are doing a temporal analysis, you can see that it's changing. It's and
No, not about temporal analysis. I am talking about the temporary domain.
temporary domain, that you can see in temporal analysis. Like you are doing an episodic data analysis. Each month you are processing 1,000 URLs, and you are observing that few URLs are changing over the time, and few are not. Those URLs which are not changing over the time are high possibilities that those are legitimate URLs, because they are there for long period of time. Legitimate URLs don't change frequently. They just improve their contents and features, services, etc. But but the malicious URLs, those domains are deleted or removed. Okay,
Okay,
so
okay.
these can be done on a platform like that. That was my idea. And if you are going for extension, that can be easily done, but might not be that much fruitful, I guess.
No, it's just a thought about the extension. We have not fully moved on with it. First, we are
Yes.
focusing on our app only, Android based. Then
Uh,
we are thinking of iOS. Then we are going to the web
yes,
because
Android
we want
development
to.
is already complex for me.
Yes, yes.
I've never done that.
Okay.
Actually, Sagar from my team has already built an extension for that, I think. Sagar, are you there? Sagar? I think he's not here right now.
Okay. Thank you very
In
much.
this context, I am interested to add some particular point. I was thinking that the 1 hour team actually done Anisha and Srimai, Ritika, Vasundhara, and Arunima did that model development of your AI content check, right? So can it be done? Means every website have some huge amount of content. Okay, that content data we are actually we have that, and for the analysis person, the content analysis and the means identification whether the content is having some manually you have done some kind of important information you have put over there and all, or it is actually entirely the AI content. Okay, so that might be might be some of the some of the websites contents more if it is more more on this informations are actually related to um, means what means a content wise analysis could be the another interesting thing. I think so. So they can join also in this particular content analysis part. What they
So,
think? Ask
one
them.
more thing I wanted to know, how is their project different from Turnitin?
Anisha, tell them.
Anyone, Anisha or someone from her team, explain your project?
Okay, your question was how it's different from Turnitin.
Yes.
Well, I think I need to look a bit more into about the exact differences. Like when we were working on the problem statement, our main focus was on handwritten images. Like we were working not with PDFs or text files or anything like that. It was more on PNG datasets, which we had created. I think one application might be that Turnitin is like more globally used for academic content, professional academic content, I think. Whereas in our data set, since it's handwritten, first of all, and second of all, it deals with students like assignment submissions or exam submissions, there is a much more chance for noises or like when you're writing something in an exam scenario, there's a chance that you will be crossing out some words, or there will be like some words that can be detected via OCR, but when someone's reading it, they can understand that it's actually crossed out and things like that. So there's a lot more noise in this one, I think.
In this particular context, I should definitely add one thing. There are many websites are specifically focused on the academics. You can check all those. Okay, so the content of those particular websites means people are learning from them. Okay, but up to how much this is actually the means their worthy to consider as an academic content really, and to read from there, this check is very important. I think so. So from that perspective, what they're developing means not only the malicious and the non-malicious categorization is important, but if you just look into that content, what exactly you read from them, I mean, every day you basically go for the many different information. This is flooded into this particular internet, and you just really look into it, and whom to trust. You people are learning from the many different places. Okay, so the content analysis from that perspective become a very important over here. Okay, so this is the very important work. It could be you can think into that direction. It might be very useful.
So for that content analysis, we can perform keyword analysis using keyword and all, so that we can know
I
how.
think this is a new perspective actually. Means, let's say, for example, you people are actually identifying the malicious or legitimate URL are there or not. That is actually you are checking. But I'm basically trying to understand that from where actually the student like you are learning every day in and day out. Are they learning from the right website? Means this is also the another perspective of your good side or bad side, means an academic perspective. That is what actually I'm going to understand, and that is what actually I'm going to describe over here. Is not only the handwritten content actually over there, in the other kind of content is also over there, and the people are reading from there. Why not to check those? And like Arkit, what exactly you people are doing over there? You are actually making some alert kind of thing, right? You people are
Yes,
making alert kind of
yes,
thing.
sir.
These are good,
Yes, sir.
means trustable, not trusted sites or apps like that. So why
Only
not
apps, sir.
trusted, and why not to score these particular websites, but just by their content, all those. Are you
Yes,
getting
sir.
me?
We will look to do
Yes,
in that
sir. Yes, sir. We
something in
have only
future.
So
thought this
this
just
particular thing is very
only one.
important. This we are learning from the many things, and most of the time the students are telling, "Sir, I have read from here." Okay, what is the trustworthiness of that particular site? whether they have developed by their own, and all those information might be correct, or some portions are correct, some portions are not correctly written. Okay, so based on that, can we go for this kind of analysis, and we can score them, rate them, and so that this particular thing means when actually a student is going into the internet, and they might be thinking that, okay, this site is good, and so we can actually go for reading of the content from there. Last, what exactly the actually right now it happened, which one is the having the higher SEO score? Definitely that is coming in the very beginning, okay, but whether we are checking that content is good or not.
Yes, sir, we can do like that. Suppose we are describing anything, we want to know about any topic, and there could be many websites which we have written about the topic. So we need to check which text is accurate, or whether it is miswritten or misinformation is not sent. Are you telling us to check that?
Comparative
Yeah,
analysis.
that could be. I'm just giving you a basic idea.
Sir.
I'm throwing a basic idea, but you people can do that one. You can discuss. Yes,
Sir,
Anisha, you.
in this direction, like what I think of you, like you basically wanted us to collaborate these three ideas into one direction, right?
Not
About
only this one, but also one another team. Already one team is actually doing one kind of thing. Let's say, for example, they are doing the work in the plagiarism. Okay, music plagiarism. Okay, who's one particular music having a similarity with the other one, means they are having a influence of one music to the another one. So there's plagiarism. Okay, that is also coming. You people are doing the work in the plagiarism, right? You are not exactly the plagiarism, but it is a AI writing. You are actually going for that.
yes,
Why
sir,
not
yes,
you
sir.
go for
Yes,
this
sir.
kind of? Because let's say,
I
for
think-
example, one internet content in a website, academic content, if it is taken from somewhere else, they are claiming that it is there by their own. Why not there is a connectivities? Why not the people will not give the their means what exactly they have taken, and the contribution of the other content from the where actually they have basically taken that one. Why not this one?
Sir,
Okay.
herein I think like doing a text analysis of it for checking AI plagiarism, we can do that. Like that one falls within our current domain as well. We already have the NLP section with us. Since in a website we are much less prone to find handwritten stuff, and it's usually much more like textual data. So we can like sort out the AI detection part with it, and I think, and for the plagiarism part, I was thinking, I'm not too sure about it. Do we need to implement web crawlers for that, for checking with other websites, like how
Yeah.
much clarity there is with other
So
websites?
what I think this the team Sentinel, Cyber Sentinel, your multimodal, multilingual, your AI check, and Bhanu, what exactly you are doing. These three team can have a very good collaboration, and you people can think about all this academic content analysis and this rating and all those things. And also, if you basically add Rituraj and Shreyan with you for the plagiarism part, and how they are actually addressing, they are going for influence, similarity, all this. You people can go work together and do some very good work over there.
So,
Yeah.
suppose we are doing comparative analysis, like Shreyan and Rituraj has done using cosine similarity. Now you are saying that for contents, whether which content is plagiarized or not, no? So why would we do that for any site? Because as they are already having their copyrights on their content.
Okay, what I'm basically telling right over here, we are not directly going into that what exactly the methodology would be there. I'm just basically going to tell that what kind of collaborative work we can do. We can think later on also. You people sit together and also brainstorm that what kind of work, what kind of methods can be implemented to do this particular thing. But this kind of collaborative work will be very interesting to move forward, I think.
Sir, I have another idea that our team can collaborate with another team also. So I have listened Kali's and Nia Mahato's work geophenome bench. They are saying that they wanted that want to make a application which will store the analytics of different plant species, and they are all analysis, so they don't have an application right now. And they have also mentioned that they would like to incorporate cybersecurity in it. So I am having interest in that also. Since we have already made an mobile app, so we have little experience, so we can collaborate in that way also, if they want.
Kali, please, Kali and Neha, talk to this one.
Yes, yes, it will be very helpful and beneficial for us as we want to make a app.
Yes, your problem statement is very unique and it is interesting when I was listening the PPT. So I am getting interest in developing an application which will be analyze the plants in a better way.
Yes.
I have a like a question, not question, like I want explanation from Devashish's presentation. Like he presented about the future, finding the future of science, if I'm correct. So I have like during the presentation, I've looked to the dataset part, and I saw that you are using a dataset based on 2014. Can you tell me why not any recent dataset?
Actually, in this side, we can find recent data set actually. Means this kind of data finding is really difficult for me and anyone. And the IMNA data set is actually old version and new version is not currently working or maybe not created. So actually, that's why I use it.
Okay, okay. Thank you.
So what I feel over here, the you people have a very means a very good idea if you collaborate and you can take it in offline later on. So that the more discussions will be there, and the discussion from the discussion might be we might have the new idea, and not only that, just a simple idea. I mean, I'm basically looking for the betterment. Means, let's say, for example, not only the paper and the journals later on, but some products level things. Means, we can go for, and out of this particular different domain, what exactly you have started exploring. Okay. So I over to Anisha. You just complete this session with just giving a closing remark. Okay.
Yes, sir. So we have a
Ma'am,
very
before ending, can I ask one final question?
yes, sure.
Yeah.
So the question is for Kali's group, like on iNaturalist, the medicinal plant identification you are creating. Can you explain me that part? Like if a plant is similar in attributes, like similar looking, for example, a tulsi and a mint, both are similar looking in my terms. Like I am not a expert biologist, so what to do that for users that are not any expert in plant biology?
Neha, could you answer?
Can you again tell the question?
Yes, like I am not an expert biologist. So for
Yes.
plants with similar looking attributes like a tulsi and a water mint or a mint plant or pudina, you can say they are both similar looking almost. So how will the user identify?
We will expand. Actually, we are expanding the data set when we will train the model based on so many data set. Then we will make a app that will take the capture that will capture the image and tell it is medicinal or means which plant or medicinal or non-medicinal. Like this, we are working on it.
Okay. Thank you.
Are we done with the group discussion? Anyone else have any question?
One more question.
Yes.
And Utsav, The PRS algorithm which you guys used, what was the accuracy of that algorithm? And suppose if there is a sudden change in an app, like a new permission has been enabled or in the discovered. So how will that permissions weightage would be redefined in that algorithm?
Thanks for the question. Firstly, I have included you in the presentation that we have evaluated our model with 3 other models. Actually, the slides were small and crisp, so we couldn't include the accuracy part. So we have already created a ROC curve where our model was 99% accurate, privacy grade was 90%, MARS marks was 88%, and POM score was 95%. And when we did the area under curve, it was representing that our algorithm is almost
Sorry for the interruption, Utsav. I think you might have not understood what exactly he is asking. He is asking that, let's say, for example, any permission,
yes, sir, I
your
will tell
app
about that
is
also.
actually changed over there. How actually your PRS score calculation will react? That is his question.
And sir, previously you also told the accuracy of our algorithm. That's why
No, accuracy we understand. What exactly he
Yes,
is
sir.
trying to understand, if the privacy part, privacy or any accessing of specific kind of data or anything
Okay, sir.
else is being changed over the period of time, then how your PRS score will actually adjust over there.
Okay, sir. So I want to take an example. Suppose we are considering LinkedIn and someone has given camera access recently. And previously, suppose LinkedIn's score was 0.5, out of which sensitivity level was 0.3. Since we consider camera as one of the most sensitive permission, which can be highly vulnerable and can be threat posing. So if we give camera access for certain reason and keep it on for many time, so PRS score will increase, and it will, and in future it will also. We are thinking of providing some kind of silent messages also, that it will show that like we have shown now in settings that this much apps are training your battery. So Sentinel will tell about that also, that this permission is causing harm to your app, like that.
As you are saying that camera permission is highly suspicious, are you guys monitoring it on the basis of just enabled permission, or even that, or only at that time while context switching, that the camera is working on background while not using that particular app? Both conditions or only that condition?
We are evaluating the fast. If it is working in the background or it has been on for very small amount of time, it will not affect the PRS. But if it is on, although camera is not required, suppose any app like which doesn't need camera access at all, like flashlight app, if it is accessing the camera, we will not only will send real-time alerts, we'll also send messages that for this app why camera is on. That is our motivation also. Then it was written in the motivation slide, like calculator app is accessing the location, why it doesn't need the location, but it is also accessing the location. So that is our motivation only.
Well, I have a last question to Utsav.
Yes,
Means,
I want to
let's say,
ask
for example, okay. So the question is, let's say, for example, we are considering the camera access.
Yes, sir.
Is a privacy issue, right? So
Yes,
you
sir.
score it negatively. Means you are actually giving the low PRS score, right?
No, sir, we are giving more magnitude so that the PRS score jumps. So more the PRS score will be towards 1, it will be high risk.
Okay,
Like
okay,
that.
got it. But
Sir,
I'm
I want to
telling,
ask something. Am I audible? Hello.
yeah.
Yes.
Sir, as Utsav is saying that they will monitor whether app which doesn't require camera access is asking for it or not, right? But the thing
Yes,
is,
yes.
when we publish any app in Play Store, they first test whether this app requires camera access or not. If it doesn't require, then it won't let the app to publish. Like there, it will be banned from there only, and user won't install it.
That's only for the apps in Play Store, no? But there are third-party apps also.
This is
Yes,
system app.
there are multiple
Yes,
APKs.
yes.
It's
Multiple
already installed in the device.
Okay.
But
Another
the
one.
system apps also, like they check means whoever developed
Like
system
Not
apps,
one
all
they
devices check. Suppose there
Ut-
is an app called App Market in Xiaomi phones. They send lot of ads. They are accessing lot of permissions. If somebody has used Xiaomi phone or Realme phone, that game market, app market, and they send lot of unnecessary, or you can say nude content also sometimes as ads. So we must monitor them, and as well we must check them also. So
One
that's
more
not
thing,
being done by
Utsav.
Play Store.
Utsav, one more thing. Let us
Yes,
consider
sir.
one particular app is really require the your camera. Okay.
Yes, sir.
Let's say, for example, in a Google Meet. Okay, Google Meeting.
Yes, sir.
So it really require the camera. Will your app mark it as a highly suspicious?
So this point, Orkit also told me before we were making the PPT. He was telling me that banking app also needs camera access, then SMS access. So we are marking it as high. We will mark it also, but there will be another some metric which will tell, although the PRS score is high, but that is okay, not alert or threatening, because that app needs that access to work properly.
Okay.
like
Got
sir, in simple words, like introducing like implementing an exceptional list. Like there will be the exceptional apps that really require those to function. That will be in our future scope.
Okay.
We have not mentioned it, but that is one of our future scope.
Fine. Okay. So we are running out of time. So you people take this discussion offline, and you go for a multiple discussion. And what exactly I have told you, go for a discussion, and go for the collaboration after that. Okay. So means over to Anisha to finish this session.
Thank you, sir. Thank you, everyone, for participating in this panel today. And we would request you to get in touch with each other and produce something really meaningful. So today we are done here. We will see all of you in the next Saturday. And if anybody has any question to anyone, you guys can contact with each other offline. Thank you.
Also, an attendance link is in the chat, so please fill that attendance sheet also.
Okay, yes. Bhanu has sent an attendance sheet in the chart. Attendance for a link. Just fill that attendance link today. And then you can leave.
Okay. Thank you.
Thank you, everyone.
Thank you, Anisha. Thank you, Vijit sir. This was a lovely session. And all the students, thank you.
Thank you so much, teachers. Thank you.
Yeah.
And everyone, please fill the form.